Okay, so we are going to be looking at uh, Matric Analytical geometry, and we are looking at finding whether or not circles intersect each other, okay, or whether they don't intersect, or whether they're tangents to each other. For the Radin students, it's page 5 and 6, okay, of your notes. Right. So, in these questions over here, okay, so it says two circles that intersect, touch in one point only, or not intersect, okay, at all, okay, depending on, okay, sorry about that, okay, the two circles will intersect, touching one point only, and not intersect at all, depending on the relationship between the length of the line segment during the centers and the sum of the radii of two circles. So the kind of questions you get are, do these two circles intersect? Okay, do they touch at one point only? Is the one circle inside the other, touch at one point, but the one's inside the other? Okay, so the different scenarios we're going to get, okay, are, the first one is, so you're going to let the radii, so big R represents the bigger radius, small r the smaller radius. So to figure out whether they touch or not, you're always going to first join up the center and find that distance mn. So in the first scenario, in figure 1, if you look at mn, the distance between the centers of the circle, okay, mn is less than the sum of the radiuses, because if you add the radiuses together, that plus that is going to be bigger, the green distances. This distance, so the distance, that radius over there, the green radius, and if you take the blue radius of circle center n, so big R plus small r, okay, those numbers, the sums of the radius, are bigger than the distance between the two circles. And if that distance is bigger, okay, the sum of the radiuses, okay, then they must intersect at 2 points only. Okay, so we say this, that in that scenario in figure 1, the two circles would intersect in 2 distinct points. Okay, in figure 2, if you take this radius over here and you add it to that radius, what you get is the distance between m and n, the two centers of the circle, and if the sum of the radius is exactly equal to, okay, the sum of the radius is exactly equal to the distance between the two centers, so if mn is equal to big R plus small r, okay, what that means is that the circles have to touch externally. Okay, so the circles, or the other words we say, the circles are tangents to each other. This circle over here is a tangent to this circle over here. They're tangents to each other. Okay, those angles then would both be 90 degrees if you drew a tangent over there. Right, then, okay, the third scenario is you go work out, you add the two radiuses together, okay, and if you take the big radius, okay, this big R, you work out that distance, big R, and you minus the small radius, that distance over there, okay, what you get, okay, is this distance mn. So if big R minus small r is equal to mn, okay, it must mean, okay, the circles touch each other internally, they're tangents to each other internally. And last of all, this is a very, it doesn't come up very often, okay, but here, you go take the distance mn, you measure it, and if it's bigger than the sum of the radiuses, so if it's bigger than that plus that, what that means, the circles do not intersect. So those are your 4 possible scenarios, the most common being usually those 3 over there, not so much that, but no, my luck, that's what comes up. So it says, showing all workings to determine if the following circles intersect in 2 distinct points, touch internally, touch internally is this scenario, touch externally, that scenario, okay, in 1 point only, okay, this scenario, okay, or they do not touch at all, that last scenario. So, what's the key idea? Okay, you're going to find the centers of both circles, and you're going to work out, okay, the distance between the centers, okay, and you're going to compare that to the sum of the radiuses. So, first of all, this circle over here, right? If I was you, I'd pause the video, go find the center of that circle. Okay, then come back to the video. Right, so to find the center of that circle, put the x's together and the y's together. We've done that. Remember, you're going to have your two brackets, x squareds, y squareds is equal to 46 plus, okay, then you're going to balance and balance. So first of all, if I go look at this bracket over here, okay, what we're going to have there, take the 6x, divide the coefficient, 6 divided by 2 is equal to 3. So you're going to get x plus 3 squared. In this scenario over here, if I look at the y's, with the x plus 3's, you've unbalanced it by 3 squared. 3 squared is 9. Okay, then you've unbalanced it by minus 2 divided by 2 is minus 1. Minus 1 squared is 1, so you've got to balance the right-hand side because you've added 9 to the left and 1 to the... So you've got to balance, add 9 to the right. You've added 1 to the left. You've got to add 1 to the right. Okay? Right, then you're going to say, so I get x plus 3 squared plus y minus 1 squared is equal to 56. So your center of this circle over here is equal to minus 3 and 1, right? And let's call that radius R1, and the radius of that circle is the square root of 46. So that's that circle over here. This circle over here, the center is 5 and 1, and your radius, I'm going to call it radius 2. Radius 2 is equal to the square root of 4, which is equal to 2. So those are my two circles. Okay. So first of all, so the one center, you don't have to draw a picture, is minus 3, 1. Minus 3, 1. Okay. The other center, so that's minus 3 and 1, is at 5, 1. So this point is minus 3, 1. This point is 5, 1. Okay? So, call the one center M, the other center N. Let's call that center M, that center N. Right? So if I find the distance between M and N, well, you could go use the distance formula. It's going to give you the right answer. Okay, but the distance between M and N, you can see because the y coordinates are the same, the distance between M and N is simply minus 3, the difference between minus 3 and 5, well, it's 3 units to there, and it's 5 units to there. Okay, so it's going to be 8. But let's say you didn't draw a picture or didn't recognize it. Okay, you'd say the distance, okay, is going to be the square root of minus 3 minus 5 squared. That's the difference between the x coordinates. The difference between the y coordinates is 1, 1 minus 1 squared. So minus 8 squared is 64. So it's root 64, which is 8, which we could have just seen from the diagram. So that's the distance between the centers. Okay, now if I look at the sum of the radiuses, radius 1 plus radius 2, well, radius 1 is root 46. Is it root 56? That's 56, sorry. That should have been a 56. 46 plus 9 plus 1, apologies. So radius 1 is root 56, and radius 2, okay, is equal to 2. So if I go root 56 plus 2, okay, so I'm going to go root 56, okay, plus 2 equal to, and you get an answer of 9,48. Okay, so what that means, the distance between the circles, okay, is equal to 8. So in other words, Mn, okay, the distance between M and M is greater than R1 plus R2. So it's this last scenario over here. Okay, the distance between M and N is bigger than R1 plus R2. Okay, so in other words, if you took the two radiuses, okay, and you added them together, it's not going to be as big as, so the sum of the radiuses, R1 plus R2, is not going to be equal to the distances between the circles. Okay, so you're going to say, therefore, the circles do not intersect. Okay. Right, so it's all about finding the centers and then comparing them. Okay. Right. So again, go find the centers of both circles. This is a bit tedious. Okay. So in this scenario over here, okay, this circle here, okay, your center of the red circle is going to be equal to 1, 3. From there you can see that. And your radius is the square root of 9, which is 3. So for the red circle, that's what you've got. A center of 1, 3 and a radius of 3. Okay, for this circle over here, okay, you're going to rewrite the circle equation as you've got the x's together, you've got the y's together, so that's fine. Remember, we're going to have x something squared plus y something squared, okay, is going to be equal to, okay, 29 plus something plus something. What's going to go in this bracket? Well, 6 divided by 2 is 3. 3 squared is 9, so you add 9 to that side. Minus 4 divided by 2, okay, is equal to minus 2. So you're going to balance it with minus 2 squared, which is 4. So you end up with x plus 3 squared plus y minus 2 squared is equal to 42. Okay, so your center is minus 3, 2, opposite signs, and your radius is equal to root 42. Let's call the center M, and that center over here, N. Okay, so the radius 1 is root 42. Okay, this center over here, okay, sorry, okay, is okay, center 1, 3, radius 3. Okay, so let's call that R2 over there. So the distance between the centers, center M and center N, MN is equal to, okay, the distance, the 1x coordinate, x1 minus x2. So it's going to be 1 minus 3, which becomes 1 plus 3 squared, plus this y coordinate, okay, which is 3 minus 2 squared, which is going to be root 16 plus 1, which is root 17. Okay, so that's the distance between the centers of the two circles. Okay, and then, so the center distance, I've got to compare that to the sum of the radiuses. So if you've got R1 plus R2, R2 is 3, R1 is root 42, so I get 3 plus root 42. Well, I don't really know how to compare those. So root 17, okay, is equal to, well, that must be 4 comma something, doesn't really matter. And 3 plus root 42, 3 plus square root of 42 is equal to 9 comma 4 something. Okay, so you've got a scenario where if you had the centers, okay, the distance, so in other words, we've got R1 plus R2. The sum of the radius is bigger than the distance between the centers, MN. And if the sum of the radius is, so if you took the one radius and the other radius, okay, there's R1, there's R2, it's bigger than the distances between the center, okay, which means, okay, that the circles, the radiuses would end there, must intersect at 2 points. So your answer for that one is the circles intersect at 2 points. Okay. So, yeah, as I said, this gets a little bit tedious. I hope that made sense. Okay, the next one at least, okay, they've done, okay, we don't have to go through the whole five equations bit. So for this circle over here, your center is equal to 3, 2, and your radius is equal to 4. For this circle over here, your center is 5, 3. Let's call that n. Let's call that m. Okay, and your radius is the square root of 4, which is 2. Okay, so if we go, the distance between the centers, distance between m and n, is the square root, okay, of the difference between the x-coordinates, which is 3 minus 5 squared, plus the difference between the y-coordinates, 2 minus 3 squared, which is the square root of 4 plus 1, which is equal to root 5. So the distance between m and n is equal to root 5. Okay, but the sum of the radiuses, okay, center is 3, 2, radius is 4, center is 5, 3. I haven't made a mistake here. Center here was minus 3, 2. Something felt wrong. Okay, the center there, sorry, was minus 3, 2, and the radius was 4. So this is going to be minus 3 minus 5 squared, which is going to be the square root of minus 8 squared, which is 64, plus 1 squared, which is 1, okay, which is equal to root 65. So the distance between m and n is equal to root 65. Just double checking my work. That's what I get. I haven't made any careless mistakes. Okay, and then if I look at, if I call this R1 and R2, R1 plus R2, okay, is equal to 4 plus 2, which is equal to 6. It's a repeat, which worries me. So your center there was minus 3, 2, and your radius was 4. Your center there was 5, 3, and your radius was 2. The sum of the radius is 4 plus 2, which is 6. The distance between the center, x1 minus 3 minus 5 squared plus 2 minus 3 squared, is minus 8 squared. 64 plus 1 is 65. Yep. So the this is going to be 8 comma something. It's a bit repetitive, this. Okay. So R1 plus R2. So Mn is bigger than R1 plus R2. Okay. So therefore, okay, the distance between the centers is bigger than the sum of the radiuses, okay, which means that the distance between the center is bigger than the sum of the radiuses, so they're never going to touch, so they don't touch. Okay, the circles won't intersect. All right. Okay, let's stop that.